Let's take a look at what Professor Phil Bell has for us today.
Hello folks.
Hello, Professor Phil.
As I mentioned in my previous video, I'll be retiring soon, so I'll have some time to figure out how to make better videos and more frequently. That said, it's not much chop doing them with little or no audience, so I would appreciate it if you would subscribe, press the like button and maybe comment on the video. And maybe even encourage a shout out from, some of those bigger channels. Anyway, in this next series of videos, which I intend to keep short and sweet, I'll be raising issues for science deniers such as flat earthers.
We are not science deniers. We love science. The problem is we don't love pseudoscience. But we love science. We're not science deniers.
And then offer them a challenge. Now, this video is dedicated to 3 flat earthers in particular, namely Rachie 5 Zeros, her BFF Anthony Riley, and flat earth researcher and ideas man Brian's Logic. Now, this video will have a fresh but deadly outcome for flat earth. Obviously, I mean for people with a modicum of intelligence. Now, if these 3 or any other flat earther is still convinced that Earth is flat after watching this video, then they're either cultists or severely intellectually handicapped.
Oh, there are other possibilities and you haven't thought about them, and we have a rebuttal to your challenge, maybe?
Now, firstly, you must agree that standing directly underneath Polaris at its zenith means that star trails must be perfectly circular. This would apply equally to the flat Earth or globe Earth models. However, as you move further and further south on the flat Earth model, the star trails will be more and more oval. This distortion will continue until it reaches the horizon as viewed near the equator. Now, as a demonstration, which I implore you to try yourself, let's consider a circular light fixture fixed to the ceiling. When you're standing directly underneath it and you look upwards directly above you, that's plumb with the floor, you see a perfect circular object. I'm sure you'll agree. But as you slowly back away, while still looking up at the light fixture, you notice it appears more and more acutely oval. So let's look at some photos of light fixtures in a corridor with a flat floor. Notice that the fixture closest to the camera is more circular than the one ahead of it. And that one is more circular than the next one. And as you can see, not only are the fixtures getting smaller, but more and more acutely oval. Now, if you look at the fixture in the far distance, meaning that you have backed up significantly, you should see that the oval shape is very, very acute. It would almost look like a straight line. And of course, it's also much smaller as it approaches your center of view. Now, I'm sure that's not a surprise here for anyone, not even for a flat earther. However, I must apologize now for spending time going over something that is so patently obvious. However, it's necessary because as sure as the sun rises every day, there will be some flat earthers who will pretend not to understand or to claim I'm setting up a straw man to burn down.
Correct. This is kind of like a straw man, isn't it? I mean, I understand what you mean now when you say about oval star trails, but there's a big problem with your examples. But we'll get into that in a minute. Let's let you carry on first.
So don't forget, flatties, you have already put yourself forward as expert navigators. So clearly you do have a map and by extension a model. If you disagree, that Polaris is in the center, then you have a lot of explaining to do with respect to your navigation prowess. You can't have it both ways.
I do disagree that the North Pole is in the centre. But I notice you say that you can't have it both ways, but then you fail to expand and to elaborate and to explain why we can't have it both ways. So, they're kind of interesting.
So let's get back to the issue at hand. Now imagine instead of a series of solid single circular light fixtures, you had one comprised of many lights arranged in a perfect circle and rotating. Again, you see a perfect circle of lights when you look up from directly underneath. And as you slowly back away, they appear more and more acutely oval and smaller the further away you go.
So, does anybody see anything wrong with his examples yet? I'm guessing the Globers won't because of all the bias, but surely somebody has to see what's wrong with his examples, right?
It's clearly just common sense and not particularly intellectually challenging, even for your low fruit fluff. So let's draw our attention to Polaris and the stars around it, which we can use to make a star trails photo using a long exposure time-lapse photograph process. If you think back to the light fixture demonstration, it should be clear to anyone born with enough mental aptitude to recognize simple shapes that the only place you could ever photograph perfect circular star trails is directly beneath Polaris at the North Pole. Anywhere else, and you would get star trails that must appear oval if the Earth is indeed flat, and you are moving away on a flat surface. This is precisely like the light fixture model. So now let's consider, what do we actually see? Well, it goes without saying that everyone in this space has seen and argued about star trails and how they appear to turn and how many there are. But I have not heard any argument about what they might look like away from the zenith. So this is what an actual photo of star trails looks like close to the equator.
Okay, so does anybody see the problem with this on the globe model? Because this is meant to be the star trails from the equator. Fair enough. Okay, so let's say you're on a ball. We'll beg the question a minute. This is a ball right now, and that is the star trails from the equator on the ball. Right. Now, zenith underneath Polaris would be where? Because if we look where Polaris is, obviously it's going to be the centre here. If we look where Polaris is, and then we was to stand underneath it, directly underneath it, where would we have to be according to this picture? According to this picture, if you was to take the geometry of, the ball seriously in that, because obviously they don't really understand the sky in that, but anyway, you'd have to be zenith. So to be directly underneath it, you would have to be here. But they believe that they're on the equator now on a ball, and therefore the North Pole would be over down here, like obviously because everything's down on a ball, so that it would have to be down over here. The North Pole would have to be over the horizon, down here somewhere. Probably a lot further down than that, but obviously there's only so much screen. So you're not going to be directly zenith to that, are you? Like, how can you be standing directly underneath that when you're going to be all the way down here somewhere? You know what I'm saying?
Clearly, this is wrong for flat Earth. Think again about the large circular light fixture. Had you backed away from it such that it is near your horizon, then as in the light fixture demonstration, the star trails would be acutely oval, and the stars close to the center bunched up very closely. So here comes my challenge. Now it's time to ask yourself some questions. How is it possible for star trails around Polaris to be circular no matter where you are standing, particularly if you're observing Polaris close to the horizon, which also means close to the equator? Now clearly that can only happen on a sphere model. Stand here, and you are looking north, and you see the star trails around Polaris as Earth spins. Stand here, and you're looking towards the north, and you will see circular star trails around Polaris as Earth spins. So finally, if this alone does not shake you to your very core and soften your belief in flat Earth nonsense, there is something seriously wrong with your intellect or your intellectual honesty. Yes, everyone, stop thumping your desk. I have deliberately not mentioned the southern star trails at the horizon. That presents even greater problems for flatties. I will deal with that in a subsequent video.
The southern star trails would work just like the northern star trails. So I don't see how it really poses more problems. It's exactly the same. The way the one works is the way the other one works. So yeah, no problem.
Now my challenge to any flat earther is to think about the issue I have raised and see if you can come up with an explanation that does not include obfuscation by throwing in the word perspective without any suitable explanation or any demonstration for that matter. It needs to be unique to flat Earth, as the solution is in this video is unique to the globe Earth. If you are a stubborn flat earther, brace yourself. Bite firmly on that bit and hold on tight. It gets worse for you. Much, much worse. I'll take you there over the next 2 to 3 videos as I get to do you slowly and methodically.
Okay, so your first problem, Professor Phil, was that you assumed the stars to be all the same height, which is kind of weird. Why would you assume that all the stars are the same height? They are not the same height. So when you did your lampshades and your different examples of lights, that was all the same altitude. There was all the same height. There was all the same level. There was all on the same plane. You didn't have them at different altitudes. So if you look at this photo here, and you imagine there was a bit more spread out, and you look at this, and you imagine Polaris is in the centre, and they was all turning. That's how you can get circular from standing underneath it. They don't have to be the same altitude to have circular star trails. They can still appear circular even though they're at different altitudes, different heights, different levels. So that's basically where you have gone wrong. You've basically put all the stars at the same level, the same altitude, and then says as you get further away they'll appear smaller and smaller and smaller and basically go into a line. But that's not true, because if they're not the same altitude, then that's not going to happen, is it? Then they're not going to appear to get smaller and smaller and smaller like that and like squish, because they're not the same altitude. You've in your examples you've got them all the same altitude, and obviously then that would happen, but they're not all the same altitude, so it's not going to happen. So as you back away, if you was underneath these looking up and they was turning, it'll look circular, and as you back away you can see that they're not going to squish because they're at different altitudes. So if there was all this level and you backed away, then sure, they would squish. But they're not all the same level. They're all different altitudes. So it's not going to squish and go oval like you claim. So that's where you have gone wrong with your assumptions and your examples, because you've just put them all the same height. So obviously if it was just the one ball here and we backed away, obviously it's going to get smaller and smaller and squish and squish and squish until it looks like a line probably. But because they're all at different altitudes, they're not going to squish. So if you look underneath from underneath, they look perfectly circular, and as you back away you would see something more like this, where you can see they are not at the same altitudes, that some are lower and some are higher. And that's basically all there is to it, Professor Phil. Your example was technically a straw man, as you put them all at the same altitude, and clearly they are not at the same altitude, because that doesn't happen, does it? So yeah. Okay, so this pink ball here on this white box represents Polaris, and the purple ones represent other stars going around. So this would be akin to looking up at the stars, even though we're looking down. It's the same thing. The direction would just be different, but the directions are relevant. This is just about how we get circular star trails. So it turns around and it creates circular star trails. They turn and circular star trails are formed. No problem. Now we go to the horizon. Not the horizon, sorry, the equator, where they're at the horizon. So now we're at the equator. Okay? And now we make it go around again. And it goes around. And as you notice, again, they are circular. Because as they come closer, they get lower. And as they go further away, they appear to get higher. And that's how you get your circular star trails. They get lower, and then they get higher as they go around, or appear to. And that's basically how you get your star trails at the equator. Now obviously this is not to scale, and distance wise and height wise and everything, so it's not entirely perfect, and obviously I've only got so big of a circle that turns, so it's not going to be perfect, but this is basically just to give you the gist of it. And the gist of it is basically this is how it would work. So as they come closer, as they go around and they get closer, like, they go lower, and as they go further away they appear to get higher, and that gives you the illusion of like circular star trails, like at the equator. So even though they're still going around the same direction, and even though they haven't changed from looking straight up or straight down in this scenario on them, you can still see that they would appear to create circular star trails around Polaris from the equator. So yeah, that's basically how it works. Now obviously this is not a perfect demonstration, as I said, as this is not to scale. This is again just to give you the gist of how it kind of works. So yeah, that's about it. Thank you and take care.